Okay, now we're going to talk about the area of a segment of a circle. Now, a segment, that's just like this little sort of thumbnail. I just think of this as a thumbnail every time I see it. This little thumbnail over here in the corner. It's got a little line segment. We call these segments chords, and then the little area that's enclosed over here is called a segment. And you see it down here as well. So if we want to find the area of that little segment, here's what we're going to consider. There's something nice about this. You notice here's the center. If you draw segments from the center to the end point of this segment, this chord, and I'll draw two from the center out. What do you know about these? Well, these two here, these are radii. This is one radius, this is another radius. And they're equal to each other, which is really, really nice. Okay? This is a radius, this is a radius. We're definitely going to use that fact. It's very helpful. So we want this area right here. I'm not sure if you noticed this already, but well, let's do this. Let's use these two circles. I left them all blank, but I'm going to give each of them a center. I'm going to try to redraw these same two radii up here, about down here, and same with this one, up here, down there-ish. Now, how can we arrive at this little thumbnail segment area? Well, let's do this. Let's take the area of the whole sector. That's what we were just doing. So we're going to take the area of the sector, and then we're going to remove something from that. What do you think? What do we remove from this sector? We're going to subtract. What can we subtract from this sector in order to arrive at this segment? If you want to pause and think about it, go ahead. I'm going to jump in. From this sector, we're going to remove this triangle. Okay? So that's this triangle right here. So we're going to take the area of the sector, subtract the area of this triangle, and that's going to give us the area of the segment. I hope you can see that. It's really important. So this triangle right in there, if we took that away, if we took this triangle away from this whole sector, what would we be left with? That little thumbnail segment piece. All right, these can get a little bit tough, but I don't think it'll be too bad. I think you all can handle it. So let's jump down here. So we've got this little segment. Let's go by what we were focusing on. The area of the sector minus the area of the triangle. Let's look at the sector here. So the area of the sector, you know, we've got a right angle. Just going to do a little mini circle. That's a right angle. So we're going to take the area of this whole sector. So if you recall, area of the sector is just going to be, you take that angle over 360, multiply it by area, pi times, and we've got a radius of 8 squared. That gives us 1/4 of 64 pi. That feels familiar. That's just 16 pi. Okay? And then from that, we're going to subtract the area of the triangle. Now that triangle, I'm going to redraw just the triangle. The triangle, it's a right triangle, got a 90-degree angle. And remember what I said about the radii? These two are, every radius in a circle is congruent, right? So this is a radius, and it's congruent to this over here. So if we know that this is 8, then this is also 8 up here. That helps us a lot. Formula for the area of a triangle, 1/2 base times height. So this area is going to be 1/2 8 times 8 again, base times height. That's so nice when we have a right triangle. And that's just going to be 32. All right, so the total area of the sector, the area of the segment is going to be 16 pi minus 32. And And that comes out to about 18.3-ish. And we've got our units as feet. And remember, area is always going to be in feet squared. There we go. All right, now the next one gets a little tougher still. But again, I know you smart kids can handle this. Let's do it. Let's first look at the area of the sector. We've got a circle. It's got a radius of 6. The measure of this arc right here is 120 degrees. So that also means the measure of this angle inside here is going to be 120. That'll come in handy later. This is 6 centimeters. So this, which is congruent to this radius, all radii are congruent in the same circle. So that's also 6. So this, the area of this sector is going to be our angle, the degree measure of the arc, over 360 times pi times 6 squared. And this is going to be equal to 1/3 times 36 pi, or in other words, that's 12 pi. Great. We've got the area of that sector. Again, the sector, let me just kind of draw it real quick. The sector is this piece. It's got the 120, that's the 6, that's a 6. You can make that out. It's this piece right here. That's the sector the area we just found right there for the sector. Now, let's do the triangle. The area of the triangle. Here's what I'm going to do. This triangle, it's shaped like this. It's an obtuse triangle. It's got a 120 degree angle right there. It's 6 and 6. I'm going to take this triangle, I'm going to rotate it around. Okay? So let me just redraw it, and I'm going to draw it much bigger so it's easier to see. How's that? That's not bad. It's not good, but it's not bad. Okay, so I just took that triangle, which was this triangle, and I just rotated it. We've got a 120 degree angle right there. This is 6, this is 6. And again, for a triangle, we want 1/2 base, so we got to find out what this base is, times height. This is our height in here. Ooh, interesting. Right, that's the height, that's our h, and then our base is this whole piece down here. This whole segment is the base. But how are we going to find these? Well, maybe you kind of sensed something here. When we drew the height of this isosceles triangle, the altitude is also going to be an angle bisector. So in other words, this angle gets cut in half, and this angle is 60 degrees. And for this right triangle, if this is 60 degrees, this is 30 degrees. Ooh, a 30, 60, 90 right triangle, that's very exciting. We know what to do with this. Let's just focus on that 30, 60, 90 triangle. The hypotenuse right here is 6. What's the short leg, the height? What is the short leg of a 30, 60, 90 triangle? It is half of the hypotenuse. So the height here is going to be 1/2 of 6, or 3. All right, and now what's the relationship between the short leg and the long leg of a 30, 60, 90? If you recall, it's just the short leg times √3, so this down here is 3√3. But be careful, the base has 2 of these, right? This is just 1/2 of the base, so you got to go all the way across. So the entire base is going to be 2 times 3√3, or in other words, 6√3. We've got a height of 3, a base of 6√3. So the area of this little triangle here is going to be 1/2 base 6 root 3 times 3. And in other words, 1/2 of 6 is 3. 3 root 3 times 3. That's 9 root 3. Ooh, not bad. So the area of the segment, the thing we were looking for in the first place, we take the sector, subtract the triangle, so it's 12 pi minus 9 root 3, and that comes out to approximately, I'm just going to go to the calculator for this one, that's 22.1 centimeters squared. That was awesome. That felt really good. Hopefully you all are really excited, and I'll see you in class with any questions. Okay, talk to you later.